All right, these are the 8.5 notes. The 8.4 notes was we had the area between two functions. We had a function on top and a function on bottom, so we used dx. The difference with these is there's going to be a function on the right and a function on the left. So when you do these integrals, you're going to take the bottom, it's the bottom y value to the top y value, and then it's going to be the right function minus the left function, dy. These are going to be integrals with respect to y. So going over here, there's only two examples on this, and we're going to graph this one, and he's kind of got this one graphed for us. We want to find the area bounded by these two functions. Now, if you notice, he's got them both solved for x, which is kind of important. So just like last time, I'm going to set the two y parts equal to each other because we want to find the intersecting values of those. So we're going to have 3 minus y squared is going to equal y plus 1. So I'm going to add y squared over. I've already got the plus y over here, and I'm going to subtract 3. And I get this equation, and then when I factor this quadratic, I get y plus 2 and y minus 1. So one intersection is y equals 1, and the other one is y equals negative 2. So that negative 2 is underneath, so it's the bottom y to the top y. Now I'm going to go ahead and graph these two. This one's a line. So what I'm actually going to do is change this to y equals x minus 1 to graph it. So that means my y-intercept is negative 1. I have a slope of 1, so this is a line going like this with a slope of 1. If I could draw it straighter, I'd be happier. And I already know because of this thing up here that my intersecting points are where y is negative 2, so this one right here, and where y is 1 is this one right here. So I really didn't need the rest of this. And now I want to do this graph right here. I want to graph this thing right here. So you got a negative y, so that means this graph, I believe, is opening to the left because of that negative. So I'm going to plug 0 in for y, which means x equals 3. So I got to come over here to 3 and 0. So I'm plugging in y values now. If I plug in 1 here, this is 3 minus 1, which is going to be 2. So that means that 2, 1. Okay, so that's that same point there. Then I'm going to plug in y equals negative 1 here. Well, negative 1 squared is still 1, and 3 minus 1 is 2. So it is also 2 minus 1. And I already know this one's intersecting here, but you could plug in negative 2 here and get this value of negative 1 out for x. But either way, this is a parabola. Man, that's a terrible parabola. This is the vertex right here. Man, that's pretty bad. I'll try to draw that better. I don't like it. It's a parabola opening to the left. Okay, now it keeps going this way and keeps going that way, but all I need is the intersecting points. So if you look here, you should notice that the top is not on top the whole time. This is why you'd want to use a dy, because what's on top changes right here. The red is still on top over here. So this is, if you look, the red is on the right the whole time, and the blue is on the left. That's why we use a dy one. So the red one's the parabola, so I'm going to use this for the right one. So this is going to be 3 minus y squared minus, and then this is the other one in terms of y, so it's y plus 1, because that's what the y part is. You want to solve these for x, and then it's that whole thing dy. So we're going to find the area of this. So I'm going to distribute this negative 1 right here. I'm going to have the integral from negative 2 to 1 of 3 minus y squared, and then I'm going to do this. I'm going to change this to plus, this to minus, and this to minus. So I'm going to change that 3 because 3 minus 1, those are like terms. So this is actually 2 minus that y squared, and then minus y, dy, and then I'm going to do my integral. So I'm going to do my power rules. So this is going to be 2y minus y cubed over 3 minus y squared over 2, and then you're going to have your lower bound of negative 2 to 1, and we're going to stick 1 in first. So we get 2 times 1 minus 1 cubed over 3 minus 1 squared over 2, and then minus, and we're going to have this stuff in parentheses, and we're going to plug the lower bound in. We get 2 minus 2 minus negative 2 cubed over 3 minus negative 2 squared over 2. Okay, and now I'm going to simplify this whole thing. Now that can be the answer in this class, but this would probably be a multiple choice question, so we're going to simplify. So we get 2 minus a third minus a half. And then this is minus all this stuff, so this is negative 4. That's negative 2 cubed, negative 8. And a negative 8 is positive 8 thirds. And then negative 2 squared is positive 4. So that's negative 4 over 2, which is minus 2. And then I'm going to distribute that negative sign. So this becomes plus, this becomes plus, this one becomes minus, this becomes plus. I'm going to add all my like terms. 2, 4, and 2 is 8. Negative a third, negative 8 is negative 3. And then I got minus a half. So this is 5 minus a half. This is 4.5, just like the first one we did a little while ago. So this shaded area here is 4.5 square units. In other words, all these squares, there would be exactly 4.5 inside here shaded. Coming down here, this one says we're doing x equals y squared minus 2. That's just parabola. And then we're doing y equals negative 1. So negative 1 is a line. Oops, y equals negative 1 is this line right here. We're doing y equals 1 is this line right there. And then the x equals e to the y is this function right here. So the shaded part, the part between all those things, is this part. So we're finding this area. And again, if you look, what's on top is not the same all the time. The y equals 1's on top here from here to here, but now the parabola is on top of the parabola. Okay, so this is why you want the right minus the left, because this thing is on the right the entire time. That's on the right the entire time. And then this is on the left the entire time. So it's red minus the green. And you're going to take the bottom y value, which is this thing right here, this negative 1 for y. So it's negative 1 to the top y is that thing, which is 1. And then the red graph was e to the y. That's the right one minus the left one. And it's this y squared minus 2. So I'm going to do the integral of this. The integral of e to the y is e to the y. The integral of negative y squared is y cubed over 3. And negative 2y is the integral of 2. And lower bound negative 1 to 1. So then I'm going to plug 1 in first. So I get e to the first minus 1 cubed over 3 minus 2 times 1 and minus, and I got to plug negatives in there. So this is e to the negative 1 minus negative 1 cubed over 3 minus 2 times negative 1. Over here I get negative e to the first minus a third minus 2 minus e to the negative 1 minus, this would be negative 1/3, so negative makes positive 1/3. And then this would be plus 2. And I have to distribute my negative sign. So this becomes plus, this becomes minus, this becomes minus, this becomes minus. So I'm going to combine like terms. So I've got e to the first, and then I'm going to make this minus 1 over e to the first, because I'm making that negative into a positive. Negative first third and negative a third is negative 2/3, and minus 2 and minus 2 is negative 4. And that's okay, or we can combine these two, the negative 4 and 2/3, and then this part. We can also get a common denominator here and combine these two, but that's good enough. So that's how you're doing the dy part. Have a good day, and I'll see you in next class.